We've spent quite a bit of time discussing symptoms. We have looked at financial performance, organizational complexity, acquisitions. We have looked inside an aerospace program. And finally, we looked at the executive cockpit, which is the final visible result that the executives receive. The next natural question actually becomes, how do we actually create this level of visibility? Because dashboards don't appear by magic, neither does organizational clarity. They emerge from an underlying architecture. Digital tools simply make that architecture visible. Let's start on the left. Notice I did not begin with SAP, Teamcenter, Power BI, or any particular software. Instead, I began with capabilities, an enterprise data platform, integrated business processes, real-time insight, governance and compliance, collaboration, security. Those are building blocks. Technology by itself doesn't solve organizational complexity. Connected information does. Now look at the top. This is really the journey every executive is trying to lead. It begins with intent. Where are we going? Why are we going there? Then comes strategic priorities. What matters most? Next comes portfolio and resource alignment. Do we actually have the people, the money, the suppliers, manufacturing capacity to execute that strategy? Only then can we reach execution. And finally, results. Notice something important. Execution sits almost in the middle. Many organizations start there. The successful ones do not. Now let's move into the 7 clarity areas. I deliberately chose the word clarity because executives rarely complain about having too much information. They complain about not trusting the information they receive. The first question is beautifully simple. Are we focused on the right priorities? Every organization has hundreds of initiatives. Only a handful truly create competitive advantage. Architecture helps ensure resources flow towards those initiatives first. Second, do we have the right people at the right time with the right skills? And this sounds obvious, yet many aerospace and capital equipment companies simultaneously experience overloaded engineering teams, idle manufacturing capacity, and delayed programs. That is not a resource shortage, it's an allocation problem. Third, has strategy actually been translated into execution? Most organizations have excellent PowerPoint strategies. Far fewer can demonstrate how each program, each engineering team, and each supplier contributes to those strategic objectives. This is where strategy becomes operational reality. Fourth, do people know who owns decisions? One of the most common causes of delay isn't technical difficulty. It is uncertainty. Who's responsible? Who's accountable? Who approves? Who decides? When ownership is unclear, decision velocity slows dramatically. Which programs are drifting off course? Not after they have failed, but while there is still time to recover. Can we actually identify them? Architecture isn't simply about reporting history. It's about creating early warning signals. Sixth, where does every executive attention belong today? Executives don't need every problem. They need the handful of problems capable of becoming tomorrow's financial surprises. Good architecture filters noise while amplifying genuine enterprise risk. Finally, perhaps the most important question. Can we trust the decisions we are making, not because they're intuitive, but because they're supported by connected, consistent, and their enterprise-wide information? Now let's move over to the right-hand side. Notice the outcomes: strategic alignment, better resource utilization, end-to-end visibility, clear accountability, faster resolution, better decisions. None of those are software features. They are the business outcomes. There is an important distinction. Companies don't buy digital transformation because they enjoy digital transformation. They invest because they want these outcomes. And then finally, look at the value chain running along the bottom. It almost tells us the whole story in one sentence. First, set intent. Then, align the organization, execute, monitor, decide, adapt, deliver impact. That's how modern enterprises should operate continuously, not once, but every budgeting cycle, not once every quarter, but every single day. So if I had to summarize this entire slide in one sentence, it would be this. Digital tools do not create better decisions. They create the visibility, traceability, and shared understanding that allow better decisions to emerge consistently across the enterprise. And ultimately, that is the source of enterprise architecture. But to give every executive the confidence that the organization they believe they are leading is actually, in fact, the same organization their teams are actually operating in. How do we actually naturally create that information? As usual, I always provide the V model. Information doesn't simply appear inside an executive cockpit. It has to travel through the organization, and this slide shows that journey. Let's begin on the left. Everything starts outside the company, not inside engineering, not inside manufacturing, out in the market. Customers change, technology changes, regulations evolve, competitors launch new products, governments announce new defense programs. All of those become market opportunities. The organization's first responsibility is simply to recognize them. Those opportunities are then translated into business opportunities. And that is where strategy begins. Which markets should we enter? Which customers should we pursue? Which technologies deserve investment? Which opportunities fit our long-term direction? Not every opportunity deserves resources. Choosing what not to do is just as important as choosing what to do. Once those opportunities have been selected, they become programs. Some are completely new. Others already exist and need additional investment. At this point, executives aren't approving engineering drawings. They're making investment decisions. Which programs deserve attention? Which programs create the greatest long-term value? That naturally leads to prioritization. And this is where architecture becomes essential, because every organization has limited resources, limited engineers, limited manufacturing capacity, limited suppliers, limited capital, limited management attention. Without a common architecture, every department creates its own priorities. With a common architecture, the enterprise creates one shared priority list. Only then should resources be allocated. Notice the sequence. We don't begin by asking who's available. We begin by asking what creates the greatest strategic value. Resources follow strategy, not the other way around. Now we reach the center of the slide, projects. This is where work actually happens. Thousands of individual engineering activities, manufacturing tasks, supplier deliverables, qualification activities, testing, certification, customer reviews, program management. Everything we have decided throughout this presentation eventually becomes work inside projects. Projects are where strategy meets reality. Now our journey moves upwards on the right-hand side. This is where visibility starts flowing back to leadership. First, we monitor project outcomes, not simply where people are busy, but where meaningful outcomes are being delivered. The milestones for technical maturity, cost, schedule, risks, quality, if somebody is yet to approve a document or somebody is yet to check a document, things like that, really intricate details of a project. Those project outcomes roll up into product portfolios. Executives rarely need to know every engineering task. They need to know whether an entire portfolio remains healthy or not. Is the portfolio still aligned with strategy? Are priorities changing? Should resources be allocated? This is portfolio management in action. Next comes expectation monitoring, perhaps the most overlooked activity in many organizations. Every program begins with expectations, delivery dates, budgets, performance targets, customer commitments, but expectations change. Architecture provides the mechanism to detect those changes early, before they can even become surprises. Eventually, products are delivered. Aircraft components, engine structures, defense systems, space, hardware. The organization fulfills its commitments, but the journey doesn't stop there, because the final step is feedback. Customers provide operational experience, manufacturing provides lessons learned, engineering discovers better solutions, suppliers identify recurring issues, service teams collect reliability data. That knowledge shouldn't disappear into separate departments. It should flow directly back into the next generation of programs. In other words, the enterprise becomes a learning system. Now look over to the right. These are the outcomes every executive ultimately wants: strategic alignment, efficient use of resources, end-to-end visibility, which is where Silk Road of Systems come, accountability, faster resolutions, better decisions. Notice something interesting. None of these outcomes mention software, because software isn't the objective. Better execution is. Digital tools simply enable them. Finally, I look along the bottom. I call this the journey to value. Find the right opportunities, assign the right resources, execute effectively, deliver the right outcomes, learn, improve, repeat. Every successful aerospace company is already attempting this cycle. The difference lies in how connected that cycle becomes. And perhaps that is the central message of this slide. A digital tool should never become another system employees are forced to update. It should become the invisible thread that connects strategy, the portfolios, projects, and then execution. We're now in the most difficult part, execution, where the real magic happens. Let's begin in the upper left. Every project begins with an idea. Perhaps a customer requests a new capability, perhaps engineering identifies an improvement, perhaps manufacturing finds a better production method. Or perhaps the market simply changes. Not every idea deserves investment. So the first step is filtering. The filter board asks a very simple question. By the way, terminologies like filter board, CCB, Fiat, etc., they are very aerospace specific. So if you're in a different industry, you don't have to worry about it. The workflow can be merged according to your systems and your terminologies. All right, so let's begin in the upper left. Every project begins with an idea. The filter board is asking a very simple question. Is this opportunity worth pursuing? That single question prevents organizations from spending resources on work that creates little value. The answer is the proposal moves to the change control board. Now we're no longer discussing the ideas, we're discussing priorities. How urgent is the request? What value does it create? Does it affect safety, certification, customers, cost, capacity? Because every approved change consumes finite engineering resources. Once approved, the engineering work begins. Here the functional interface, allocation, and design requirements are developed. In aerospace, this stage is critical. So once the filter board does their work, you have the CCB, which is the change control board, and then you have the Fiat development, which is nothing but your functional impact that is signed and approved by all different heads of different technical authorities, and have the project, which is officially ready to begin. Resource planning should be developed after this, because once we know that there are set number of projects, we can develop the resources accordingly. Projects are properly planned. Then you have monitoring of your resources. Projects are monitored. The requirements of the Fiat that is signed here, the requirements, they're monitored if it's delivered or not. The Fiat requirements are accepted by an NQO or external authority if it is needed. For aerospace and military programs, it is needed, but for many other organizations, of course, it is not an issue. There's also medical device organizations that actually require external authorities to approve. Fiat is closed through IETP released and monitored. Requirements are baselined through the IETP release and continuously monitored. What is an IETP? It's an interactive electronic technical publication. It refers to the digital manuals and diagnostic guides used by technicians and engineers to maintain, troubleshoot, and operate complex aircraft and defense systems. This is basically, it's a set of operating manuals. Let's go one level deeper. We've just looked at how projects are selected, planned, and governed. But aerospace doesn't simply deliver projects. It delivers certified products, and that changes everything. Because in aerospace, changing a component isn't as simple as issuing a new drawing or updating a specification. Each modification has to be justified. Every assumption has to be documented. Every decision has to be supported by evidence, and that's exactly what this slide represents. Everything begins with what is called the Modification Substantiation Report, or the MSR. Think of it as the technical story behind every engineering change. It explains what is changing, why it needs to change, how it has been analyzed, and why it remains safe. The MSR becomes the thread that connects the entire engineering process. The first step is planning. Before anyone changes a drawing, before manufacturing receives new instructions, before suppliers produce a new component, the modification itself has to be clearly defined. What problem are we solving? What assumptions are we making? What systems should be affected? This is where the engineering journey truly begins. Next comes substantiation. And this is one of the defining characteristics of aerospace engineering. Nothing is accepted because somebody believes it will work. It must be demonstrated. Engineers perform analysis, structural assessments, safety evaluations, compliance studies, simulation, testing. Evidence is collected until the proposed modification can be defended objectively, but judgment alone is never enough. That evidence is then documented, not simply stored, structured. Every calculation, assumption, test results, every supporting argument, the goal is straightforward. Months or even years later, another engineer should still be able to understand exactly why that decision was made. Knowledge should survive the people who created it. Naturally, those documents are reviewed, checked, verified, approved. Again, it isn't unnecessary administration. It's independent verification. Someone else asks, does the evidence actually support the conclusion? Because in aerospace, confidence comes from independent challenges. Only after approval can implementation begin. Engineering changes are prepared for release. Manufacturing planning is updated. Implementation activities are scheduled. Resources are committed. The organization moves from analysis to execution. Eventually, the substantiated modification is formally authorized. Only then can it enter production. Notice the sequence. Authorization happens at the end, not at the beginning. That order protects both safety and traceability. Now the process turns upwards. The modification is implemented. External authorities or customers, where required, they review the accepted change. This is an important reminder, by the way. Aerospace companies don't certify themselves in isolation. Many changes require external confidence as well as internal confidence. Once accepted, the modification becomes operational, but the journey still isn't finished because reality always teaches us something. Perhaps the modification performs exactly as expected. Perhaps it reveals new insights. Perhaps unexpected behavior appears years later. That information shouldn't disappear. It should be connected back to the original engineering decision, which brings us to the final step. Lessons learned. This may be one of the most valuable outputs of the entire process. Every successful modification, every unexpected issue, every investigation, corrective action becomes knowledge for the next generation of engineers. In other words, the organization becomes progressively far smarter. Now look at the center of the slide. I deliberately highlighted the process principles. Safety first, compliance always, evidence over opinion, collaboration across disciplines, continuous improvement. Those aren't simply engineering values, they're architectural values, because architecture exists to ensure these principles remain consistent across every program, every site, every country, and every engineering team. Finally, look over to the right. What are we really trying to achieve here? Safe products? Regulatory compliance, efficient execution, complete traceability, the knowledge capture, these are the visible outcomes. But underneath them sits something more valuable, confidence. Confidence that every engineering decision can be traced, understood, verified, and defended. Now, you might think that aerospace companies, historically aerospace companies are quite traditional in nature and they have existed since a long time. So you must think that this is already established. On paper, yes, they're already established. The processes are already there. But oftentimes what happens is that there are more number of projects than the number of days that people are working. It's enormously complicated. Engineers are constantly burdened with backlog. Projects take almost sometimes 10 years to finish. So there's a significant backlog on the number of documents that are to be internally approved and then externally approved. So there is quite a lot of challenges within the aerospace industry. Silk Road of Systems definitely come in as a healing agent. We are not here to say, all right, please use our software. Silk Root of System does not own any software. Silk Root of Systems own experience. We own the understanding of how information should flow seamlessly from one person to other. And yes, of course, a lot of those information is intuitive, but then you want your engineers and you want your managers to focus on the present and not be busy with the architecture, correct? And that is where you call up and you ask Silk Root of Systems to come and help you, help your organization. Digital tools don't replace engineering judgment. They preserve it, they connect it, they make it traceable across thousands of decisions, hundreds of projects, and decades of product life.